Hi everyone, welcome back to the channel, and today on solve Leetcode daily challenge problem number 300, longest increasing subsequence. So we will first check out the problem statement, then we'll check out the process we are going to use, and at the end we'll see the code as well. So starting with the problem statement, it is given that we will get an array nums and we have to return the length of longest strictly increasing subsequence. Okay, so if you see this example, or let's take example number 2, 010323. The longest increasing subsequence is 0123, right? So that's why the length of the longest subsequence is given as 4. And if you want to know about subsequence, it is basically any sequence or any arrangement of elements from a given sequence. Okay, you cannot change the indexes of that, or you cannot change the position of it. If you are taking, for example, 10 2 5 7, you cannot make it 2 5 10 7. Okay, so that is called a subsequence. So what we'll do to solve this is we are going to use dynamic programming to solve this question. And how we're going to do that? So we'll first start from the backward, like we'll start from the last element. Okay, so before that, what we are doing, we have initialized an array. Okay, this will be a DP array. I have named it result. Okay, and we will initialize all the elements with 1, because of course, it will at least have itself in it. Like for example, if I'm just considering 3, so this is a subsequence in itself as well, so that's why we have initialized it with 1. So what we are going to do with this, we will iterate all these elements one by one. And what we will do, for example, let's say I am at this element. Okay, I am at this 3. Now I will see if I can add this 3 from any of the subsequence which we have already calculated before that. Okay, for example, in this case, the value of 3. Okay, like this subsequence has one element. Can we add 2 in it? Yes, because why? 2 is smaller than 3, so we can add 2 in it. So the largest subsequence in having this element will be 2. Okay, now we come to 3 again. Is it possible to add 3 in this subsequence? No. Why? Because 2 was smaller than 3, right? So we cannot add this 3 in it. So we will just, we won't do anything and we'll keep it 1. Okay, so this is what we're going to do. So let's just do a dry run for it. So for example, let's say we started with 1. Okay, so the largest subsequence having this element is 1. Okay, now we will simply check if, so I'm writing a condition over here, nums of I is less than nums of j. Okay, so this is my I pointer now. Okay, my j pointer starts from I plus 1 and goes till the end point. Okay, so this is my I, this is the j. Is element at I is less than j, like element at j? Yes, so we can add this. And what it will be, the current value is 1, but it will be maximum of 1 plus 1 plus, let's say this is result, right? So result of j, or result of like the current value, or 1 plus the largest subsequence possible till the next element. Okay, so this will become 2 and 1, so it will be changed to 2 now. Okay, similarly, now we'll move our I and j to the next elements. So now this will become I, this will become j. Okay, I will again check if this is less than element at index I is less than element at index j. No, then we'll move on, we won't do anything. This j will again be updated, so we'll update this j. Now this is the j. Is it small? No, we won't do anything and it will remain the same. Okay, now we will again update our pointers. This is I now, will start with I plus 1, like the j pointer will start from this. So is this possible? Yes. So what will be the largest value? 2, because 2 1 plus 1 2. Okay, now we'll change the j pointer again. This is by j. So what if we have this, then 1 or 3, right? Or 2 or 3, let's say, because we have already seen 2 with this element, right? So 2 comma 3, so it will be 3 now. So current maximum is 3. And again we'll update the pointer. 0 comma 3 possible, but it will say 3 because 1 plus 1 is 2, which is less than 3. Okay, so this is the process which we are going to follow for all the elements. And at the end, what we'll do, we will simply return the maximum of result, or res, like this thing. Okay, and this is basically the DP array which we talked about. Okay, so let's check out the solution now. So this is the simplest solution. So what we have done over here, we have initialized the DP array with ones, because of course, like the smallest subsequence will have at least one element, that is itself. Now what we are doing, we have started an iteration from backwards. Okay, so we are starting with the last index and we are going till 0th index. Last index is not included, and we are decrementing one step at a time. For the j pointer, we started with I plus 1 and we'll go to the last element. Okay, we are checking if the element at I index is less than an element at j index. Yes, then what we are doing, we are taking the maximum of current value, or 1 plus the largest subsequence possible till the next element, till the element at j. Okay, we took this, and at the end we are simply returning the maximum from the result area. So let's check out the test cases. Yep, so the test cases got cleared, submitted for further evaluation now. And okay, it's still processing. Yeah, so as you can see, the solution got accepted, and I would say like we have performed fairly well enough. So yeah, this was the solution, guys. Thanks a ton for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.